Good morning. So you get stuck with me. I was going to send my COO, but he has to take care of his son this week. How do I want to. Okay, looks good. So, I'm the CEO and president of the ISS National Lab, also the principal investigator. This happens to be Glenn Research Center Retired Directors Reunion. So hopefully Marla will learn something today. So in the ISS National Lab, we operate 50% of the US OS science research on the ISS. And basically, all the research that's done that doesn't support NASA's exploration mission is managed by the National Lab. The organization I manage is called the Center for the Advancement of Science in Space. We operate under a cooperative agreement with NASA. We're a non-for-profit 501c3, and we were created solely to operate the International Space Station National Lab. Next chart. Okay, let me see. I think this one here. Yes. So, the ISS obviously is a lab off the Earth, but it's for the Earth. In fact, that's written into the legislation. All of the science we do have to benefit humans here on the Earth. And our research portfolio includes in-space manufacturing. That includes things like additive manufacturing. Probably the biggest area of interest at this point is pharmaceuticals and organoids, and you'll probably be hearing a lot about that research in the near future. A company we work with called Redwire recently printed an artificial cartilage in space, and it's undergoing tests. But if that work is the results come out as we expect, it could be a very game-changing technology for humans here on Earth. We work in, obviously, biology and biotech, a lot of work in stem cells, fluids and materials. Basically, it's fundamental science looking at fluid transport and material science. Earth and space observations, as it was previously noted, a lot of Earth observation occurs from the ISS. Technology demonstrations covers a myriad of technologies that we're trying to verify work in the space environment. So small companies that are trying to test things like optical communication systems use our allocation to do their work. And finally, we do have a prolific STEM and workforce development program. We work with some people here on the island. I don't see Luis Torres here, but if you don't know Engine 4, you should know them. I think they have an outstanding program in coding and robotics, and really, really very relevant to the work we do. So our research, we fund $6.5 million of work to small companies and researchers across the United States. Those come in as grants that basically support hosting a researcher's payload on the ISS. We also leverage about another $4.6 million of NASA funding in the mission integration and operations. So that total comes in at about $11.1 million. But what it doesn't include is the value of the allocation, which is the up mass, the down mass, and the astronaut time, which adds about another $2 to $4 million per payload. And if you add all of that up, it's over $200 million worth of research that we do every year. So pretty significant figure. This is obviously one of our tech dev projects. And as you can see, the crew, very active in interaction. One of the things we're starting to see, though, is the cost of crew time is very, very expensive. It's about $200,000 an hour to have an astronaut operate a research project in space. So what's happening today is that a lot of the companies are developing the experiments so that with very little astronaut interaction, we can run a full experiment. This is one of the in-space production applications that we're working on. This is called tissue chips, and the intent of this research is to basically use it as a way to test the efficacy and the toxicity of drugs with human cells. And what that will end up doing is hopefully in the foreseeable future, we'll be able to, instead of running clinical trials on animals, we'll be able to actually run these clinical trials using actual human tissues and be able to see how do they work and how toxic they are. Pharmaceutical work, you may have heard of Keytruda. It's a drug made by Merck, which is used by a lot of cancer patients. It's based on a protein crystal. The initial formulation of Keytruda uses a crystal that was manufactured on Earth, which is, it's not consistently sized throughout the formulation. And so Merck had a theory that if they could make seed crystals in space, they could lower the dosing of the Keytruda, get the same or a better medical effect, and at the end of the day, be less toxic to the patient. So that's some of the work we're doing there. Again, this is tissue and biomanufacturing. What you're seeing here is some stem cell work that we're doing. Again, really looking at possible treatments of cancer and things like that. Advanced materials manufacturing, one of the things we're very actively pursuing right now is working with NIST on CHIPS Act work. There's some thoughts, and Marla and I have this experience at NASA Glenn, materials that you cannot make high-quality crystals on Earth, like silicon carbide, which have very unique properties. We believe we're going to be able to make high-quality, low-defect crystals in space, and that's kind of one of the focus areas for the future. Fundamental science. Again, trying to understand the physics, the chemistry, the biology, so that we can develop new technologies. And STEM education and workforce development. We have an extensive program. We spend 10% of our funding on STEM education. We reach an incredible number of students, but what we really want to do is start to measure the impact of this outreach that we're doing. And then finally, here's our FY24 solicitation plan. I'd highlight to you a project which is already in process. It's called Igniting Innovation. It's a project that's going to provide multi-million-dollar funding to a PI with multi-year opportunities to fly your experiment. And what we're really hoping to do is, instead of running one-off experiments, is provide a researcher with the ability to lay out a research plan that might cover 5, 6, 7 flights and really advance the technology, and hopefully we can gain some benefit that way. Our project flow, predominantly we work with the principal investigators. Those tend to be researchers at universities across the country. Most of them need a lot of hand-holding because they're usually first-time users and investigators in space. We pair them up with a commercial company. We call them implementation partners that are actually able to help them host their mission on the ISS, or we pair them up with a commercial service provider. The big difference between the IPs and the CSPs is the CSPs actually have their own facilities on the ISS that they use to implement the science. And here's a few of the companies we work with and universities. And you can see very large population. This is not all inclusive. We work with about 50 companies that actually do the hosting of the payloads, but we have over 300 researchers that we work with on ISS. And this kind of lays out the lines of business. And then finally, a little bit of work on some information about some of the R&D highlights that we've had. And again, it's across a lot of domains of research. Within our investor network, we work with these small companies that host payloads to raise venture capital. And what we've been able to do is, since we've made our first award, we measure how much capital they're able to raise in the venture markets. And to date, we've raised about $1.2 billion of venture capital subsequent to getting an ISS NL award. This is our dashboard. As you can see, we have 175 industry projects, 159 academic projects. We have 16 commercial service providers, 36 implementation partners, and the sum of those, that's 50 companies roughly. That's really the commercial element, these companies that are trying to create opportunities in space. We have a 300-member investor network, and like I said, within the federal government, we not only work with NASA, but we have extensive programs with DoD, NSF, and NIH. And that's basically it, unless there's some questions. I will share with you, I appreciated all the questions I heard today about a spaceport. Don't let yourselves go broke funding a spaceport here. There's about 9 in the U.S. that have never made $1. So, you need to very carefully go about your plan to implement a spaceport, because it's not just a question of building and they will come. I do believe Puerto Rico has a very unique competitive advantage when it comes to a spaceport, being roughly 18 degrees north of the equator, significant benefit to companies that are launching in space to be able to get a more payload for less cost. And I think that could be a real selling point, in addition to the great climate and wonderful food here in Puerto Rico. So that's all I have for you. And if you've got any questions, I'll be here for a little while, but thank you very much for your attention.